Well, the science of meteorology is always interesting. And when it comes to precipitation, for example, not all precipitation forms in the same way, whether it's snow in the winter or thunderstorms in the summer. Now, I'm showing you a map here of temperatures at 18,000 feet above us. Well, you might be thinking, what does this have to do with our weather, right? Because so often when we talk about temperatures, we're talking about surface temperatures, how it feels outside, because that dictates what we wear, right? Whether it's a short sleeve day or a long sleeve day or a winter coat type day. But it's not only important to look at what's going on at the surface, we also have to look at what's going on throughout the atmosphere. So let's talk about this here. As we look at 18,000 feet, look at this really cold air coming right over Wisconsin above our heads. Well, oftentimes we will see a big temperature difference between what we feel at the Earth's surface and what's going on at 18,000 feet over our heads. Now, we know that if we were to get into a hot air balloon and go up, it gets colder, right? The higher up we go. But sometimes, depending on weather conditions and storm systems, it can get very cold over our heads. And temperatures can really drop below zero at 18,000 feet, for example, and that leads to instability in the atmosphere. So think about this. On a summertime day where it's warm at the surface, a short sleeves kind of day at the surface, but then you go up and it gets really, really cold at 18,000 feet. Well, that creates instability in the atmosphere, which then generates precipitation. In the wintertime, we can have what we call instability snow showers. In the spring and summertime, in the warmer months, we can get those afternoon popcorn variety thunderstorms. And it pops up with the heating of the day, so they get especially numerous during the afternoon. Why is that? Well, that's when we're at our warmest, right? Here at the Earth's surface. And so as the Earth heats up, as we heat up here at the surface, those thunderstorms bubble up. And then what happens after sunset? Well, the sun goes down and we start to cool down, right? So that temperature difference between the surface and 18,000 feet gets lower, so the instability is not as strong in the evening as it is with peak heating. But again, it's not just what happens at the Earth's surface. We've also got to look above our heads to see what's going on with those temperatures, because that can lead to some snow in the winter or popcorn thunderstorms in the summer.